Okay, let's analyze this circuit. This is a field effect transistors. So to the left I see I have this N type of silicon or just a semiconductor material in the shape of a bar. So N type bar, and inside the N type semiconductor I have two P regions. So that forms two PN junctions. Now on the sides of the P regions I have two pins called as gate. So they are shorted to each other, that's why they will be common pin. And now there is a source and the drain, there are another two pins, so total three pins for this device. Across drain and source I apply a voltage source with a positive connected to the drain and the negative of the battery connected to the source. As a result, I see that N-type semiconductor, which is the blue region, acts as a resistor through which this voltage source supplies a current, and that current flows from drain to source as indicated by the direction of the current. Remember, because of the formation of the two PN junctions as shown in the figure, there will be a depletion regions into the channel of the field effect transistor. This blue region is called as channel of the transistor. And when you have a picture as shown where N type of material is there and the current flows through that, it is called as N channel FET. This is called N channel FET. Now let us have a look at the circuit in the right. So you have positive connected to the gate, positive to connected to the gate, and negative connected to the source. So it is same as what you see in the left diagram. But now in the picture to the right you have a battery applied to the gate with respect to source, where the negative voltage is applied to the gate of the transistor as shown. Remember, I said the gate is common, so on either side of this N type semiconductor you have gate pins, and to which the negative potential is applied, and the positive of this battery is connected to the source. Now due to this we see that on the P type of semiconductor you have a negative voltage applied, and on the drain side of the N type of semiconductor you have positive voltage applied to it. So N is connected to the positive and the P is connected to the negative. So this PN junction towards the drain and the gate is reverse bias. That's why we see there is a depletion region shown in the figure. Now similarly, the source pin of the N type of material is connected to the negative potential, and the gate is connected to the negative potential as well. Or you can say the source is connected to the positive here and the gate is connected to the negative. So this side of the PN junction is also reverse bias, and that's why you see this depletion region right there. So more the negative voltage you apply to the gate, bigger the depletion region goes, bigger the depletion region gets. And due to this action, the current that is flowing from drain to source gets decreased as the depletion region starts increasing. So the channel gets narrower and narrower, and there is a less and less current flowing from drain. Now let's say what happens if you apply a positive voltage to the gate with respect to source, and you have a positive voltage at drain with respect to source. So with the positive applied to the gate, it means the P type of semiconductor receives the positive voltage right here on either side of the semiconductor bar of N channel, and the N is connected to the negative potential. So because of that, the depletion regions on either side gets narrower, and there is a wider channel opening that allows the large amount of current to flow from drain to source. So this is how the N channel field effect transistor works, and due to applied biasing, the gate the current from drain to source can be controlled. So hope you understood this explanation. If you like the video, share with others and subscribe to the channel please.